with the aim to create a high-quality academic forum for scientists, domestic and foreign experts on recent developments and prospective trends in intelligence and computing research, especially in the fields of electrical and electronics, engineering, mechatronics, and information technology. Today, the 3rd of June 2020, Phú Gia Một University is honored to collaborate with Calendar Institute of Industrial Technology, Odisha, India, to hold the 5th International Conference on Research in Intelligence and Computing in Engineering, PRICE 2020. PRICE 2020 is the 5th international conference following the other 4 successful conferences in Nepal, India, March 2016, Uttarakhand, India 2017, El Salvador 2018, and Hanoi, Vietnam 2019. The conference this month is being held online using Microsoft Teams. In order to classify the knowledge as well as to have your own conveniently gain a deeper insight into the fields mentioned, the conference is divided into 7 different sessions. The first session about the smart manufacturing industry 4.0. Chair Dr. Lê Chí Hiếu Lê and Dr. Anh Mỹ Chu and Dr. Trần Đức Trăng. Session 2, Deeper Learning for Intelligent System, Chair Dr. Bùi Thanh Hùng and Dr. Raghvendra. Session 3, Artificial Intelligence and Machine Learning, Dr. Association Professor Lê Tuấn Anh and Dr. Roger Fisher Master. Session 4, IoT Ecosystem and Application, Chair Dr. Nguyễn Văn Tân and Dr. Subi Phồn. Session 5, Signal Processing and Network Communication, Dr. Nguyễn Hà Huy Cường and Dr. Rashid Agarwal. Session 6, Advanced Emerging AI and Healthcare Applications, Dr. Hoàng Mạnh Hà and Dr. Matthew Curry. Session 7, Wireless Sensor Network and Applications, Dr. Hồ Đức Trung and Dr. Prasad Kumar. Okay, now let's begin with session 2 about deep learning for intelligent systems. We invite Dr. Bùi Thanh Hùng to continue with this session.
Okay, thank you for your introduction. Now we will begin with the section 2. This section is chaired by me, Bùi Thanh Hùng, and Dr. Kumar. Now let's begin with the first answer with title. The capabilities to classify cumulonimbus cloud using region CNN. Welcome the author this paper present. With the paper are there any other of this paper in this room?
Yes, sir. Myself, Shritikanta Chattopadhyay. I am present. Can I start my presentation? Sir, myself, Shishikanta Chattopadhyay. Can I start my presentation?
Yes, yes. Please continue your presentation.
Okay, okay, sir. Is it visible? Is it shared? Are you seeing it? So, good morning to all of you.
Yes, good morning.
Myself, Shishikanta Chattopadhyay, Assistant Professor of the Department of Computer Science and Engineering, Raghvendra University, Kolkata, India. And my paper title is A Comparative Study to Classify Cumulonimbus Cloud Using Pre-trained CNN. Along with me, the other authors of this paper are Shobhit Pal, Pinaki Pratima Acharya, and Sonali Bhattacharya. So, this is the abstract of our paper. Here, actually, we have dealt with a special type of cloud that is the main cause of thunderstorm. Actually, we worked with three different type of clouds, namely stratus cloud, cirrus cloud, and cumulonimbus cloud, where our primary objective is to classify the cumulonimbus cloud. Actually, all type of clouds we have to classify so that we can say that there is a chance of thunderstorm is in a particular area or not. We have done this with the help of two, we have used two fields of computer science, that is namely digital image processing and the deep learning. So here the AlexNet and GoogleNet, two pre-trained convolutional neural network we have used for classifying this cloud, and that we have done, the simulation we have done with MATLAB, and the AlexNet as well as GoogleNet is actually giving the accuracy of almost 82% accuracy. Okay. Now, the main objective of our paper is to classify the type of cloud from cloud image automatically, because we have taken the natural images. That image consists of, along with the cloud part, it also has some other parts also, other objects also, like trees, houses, roads, ocean, everything. So those are the natural images. So obviously, we have to classify from that image. We have to classify the corresponding cumulonimbus cloud images. That is our first purpose, and the second objective is to identify the cumulonimbus cloud, because this cumulonimbus cloud is actually the main cause of thunderstorm. Not all the other clouds are forming thunderstorm, but cumulonimbus cloud does. So that is our primary objective. Now, before going to the results and the simulations and all the other parts of this, first I wish to say something about those clouds that we have dealing with. Although there are different type of clouds are available in sky, but we have mainly dealing with the three different basic types of clouds, namely cirrus cloud, stratus cloud, and cumulus cloud, not cumulonimbus. But cumulus cloud is actually gives some pleasant weather, but in some later time, this cumulus cloud can be transformed into cumulonimbus cloud. That cumulonimbus cloud is causes the thunderstorm. Obviously, there are some lot of other factors are also associated with this. Not only cumulus cloud is not the only cause. pressure difference, temperature, moisture, humidity. There are a lot of factors are there. But along with them, this cumulus cloud, when it will be transformed to the cumulonimbus cloud, then the thunderstorm may cause on that particular area. So this cumulonimbus cloud is by shape or structure, these have a lot of difference with all the other type of clouds. Mainly, this cumulonimbus cloud is detected easily by its anvil shaped nature. Okay. And that I have already mentioned previously that the main ingredient of thunderstorm is cumulonimbus cloud. Now the second, the first domain of computer science that we have used for our research purpose, that is image segmentation or digital image segmentation. That is actually one of the fundamental operation in digital image processing. We know that digital image processing have three types, that is low level, mid level and high level, and image segmentation is actually belongs to the medium level or mid level digital image processing. So here actually in image segmentation, actually some particular area of interest will be segmented from an image. So here our area of interest will be only the cloud part that I have already mentioned, that we have taken the real life images. So there are a lot of other objects are also present in the image along with clouds. So we are actually segmenting only the cloud part. There are different algorithms are there that we can use for segmenting those objects, but among them, marker controlled watershed segmentation technique is the most common and widely used. Why it is so? Because it works on the morphological operations, and these morphological operations are actually the collection of different set theory operations, basic and advanced set theory operations. Those set theory operations include dilation, erosion, opening, closing. There are different operations are there, and with the help of or the mixture of these basic and advanced operations, some complex algorithms are also there. Those are mainly application specific, boundary extraction, region filling, etc. Now, I'm coming to the second field of computer science that we have used in this research work, that is deep learning. So here we have used the pre-trained convolutional neural network, AlexNet and GoogleNet. This pre-trained network is already trained with 1.2 million real-life images. These images are actually the part of a very popular very popular database, image database, that is ImageNet database. And when this AlexNet and GoogleNet is already trained with those images, then they can classify among 1,000 real-life objects. Okay, successfully it can classify among 1,000 real-life objects. Those 1,000 real-life objects include different types of whale species, fish species. There are some computer peripherals like printers, scanner, keyboard, mouse, monitors. These things, this type of real-life things can be easily classified by both AlexNet and Google. So our objective will be classify the cumulonimbus cloud as one of these objects. So if we are doing in that way, that if AlexNet and GoogleNet can successfully classify 1,000 real-life objects, then why not cumulonimbus cloud? If we are thinking that cumulonimbus cloud is also one of the real-life objects, okay, then it can also classify cumulonimbus cloud as a real-life object, like this 1,000 classes. So here is the methodology of our paper. We have taken total 545 different real-life images, and these images consist of all kinds of objects along with the cloud part. After that, in step 2, only the cloud portion is segmented using marker controlled watershed segmentation. So that cloud portion, that's why this object of interest, and this cloud portion, after segmenting it, there are total 545 different cloud segments will be there. Those are also considered as a digital image. So among those, among those 80% are given as a training data to both AliceNet and GoogleNet. So when 80% is already given for the training purpose, then transfer learning is applied. That we know that since we are using AliceNet and GoogleNet, and those are pre-trained network, that's why to train a pre-trained network with a new set of data, that is this 80% of the images, segmented images, the transfer learning will be used. So with the help of this, the transfer learning will be processed, and after this transfer learning, that means training is over. After that, the remaining 20% will be used for the validation result, that it is successfully validating the result or not. That is, it is successfully classifying the cumulonimbus cloud or all the other clouds or not. So after giving that, we have seen that the validation finishes with 82% accuracy. 82% means it is 81.65% accuracy was there. So those are the corresponding simulation purposes here. This is the transfer learning process for AliceNet. Here the accuracy is in increasing manner and the corresponding loss is in decreasing manner. Here the validation accuracy, when it is complete, the simulation has been completed, then the validation accuracy was 81.65% and the total elapsed time was 96 minutes 13 seconds. And here the learning rate we have given as 0.0001. We can change it also, no problem. But when we have given the learning rate for AliceNet, is this the same thing we will provide for GoogleNet also. So in the GoogleNet also, we have given the same parameters, same things. So here the validation accuracy is also 82% approximately, but the corresponding elapsed time, that is the total simulation time, was much larger than the AliceNet. Here it is 309 minutes 49 seconds. And here also accuracy is in the increasing manner and the corresponding loss is in decreasing manner. So, and the learning rate was 0.0001. So, after that, the result was, this is actually the validation result, and validation, we have given the validation result for both AliceNet and GoogleNet. Here, after validating this, the Strata, Cirrus, and the cumulonimbus cloud, both these three type of clouds are successfully classifying. Maybe with some another set of validation result, maybe some of the prediction will be not correct. Here, all the predictions is correct, but with some another set of validation result, maybe the correction, the classification will be not 100% correct, because the accuracy was not 100%, it was 81.65%. So here, this is the anvil shaped nature of this cumulonimbus cloud. So this cumulonimbus cloud, the classifying of this, that was our primary objective. So these are the validation result of AliceNet. Similarly, the same for GoogleNet. In this GoogleNet also, it is taking random function we have used. So that's why it is taking in its own that how many Cirrus, Stratus, and cumulonimbus cloud it will take as a validation result. So these are the cumulonimbus cloud here. These are the anvil shape nature. This is called anvil shape. Okay, so that's why this cumulonimbus cloud, that one anvil shape, this one anvil shape. So these clouds are successfully classifying by this both AliceNet and GoogleNet. So the conclusion of our paper, that is both CNN is approximately giving the same accuracy that we have seen already. Both are giving almost at 82% accuracy, but it may differ with different training sets. So obviously, when we have given only 545 different images, but if we are increasing the number of training data, then the corresponding everything will be changed. Actually, the training will be more effective. The corresponding validation result, the accuracy level will be improved. Okay, so everything will differ when we are increasing the training set, that is the number of training data. AliceNet is much faster than GoogleNet, obviously, because AliceNet, the total, if all the other parameters are same, then AliceNet is completing the total simulation in 96 minutes, where GoogleNet is taking total 310 10 minutes. So obviously AlexNet is much faster than GoogleNet, and it's obvious because AlexNet is much smaller network than GoogleNet. Okay, so these are the comparison between the with respect to the simulation time. Yes, this is for AlexNet and this is for GoogleNet. Now, the future work that can be processed with this existing work, that is increase the training set. That is, we have used here the 545 images. If we had increased this, then corresponding result will be improved. It will give better result if time can be considered, because cumulonimbus cloud is formed from cumulus cloud. Actually, cumulonimbus cloud is formed from the cumulus cloud, but not always. Since I have already mentioned that cumulus cloud is actually giving pleasant weather, but when cumulus cloud is transformed into the cumulonimbus cloud, then that will cause that savage weather like thunderstorm. So if the time constraint we are also importing into our system, then the corresponding we can more efficiently we can say the chance of thunderstorm on a particular area. Some other CNN may be used like VGG16, VGG19. So those VGG16, VGG19, both all are the pre-trained network like AlexNet and GoogleNet with different network architecture. So some other CNN can also be used, and we don't know that the corresponding validation accuracy will be improved or decreased if we are using this tool. Own CNN can be used instead of pre-trained one. We have used here pre-trained network, but own CNN can also be used. But in that case, more training data is required for training purpose, and simulation time will also vary. Obviously, because own CNN for training purpose at least 10,000. If we have our own CNN for this same work, but there total training data is required is almost 10,000 at least. It will be, if it was more than 10,000, then it will be better. At least 10,000 image data is required. But we did not have this amount of training data, so that's why we have used pre-trained CNN. Okay, see here in the AlexNet and GoogleNet, those are also pre-trained network, and those were trained with 1.2 million training data. So obviously, this is actually the future work that it can be processed with our existing work. So thank you, sir.
Professor Chattopadhyay,
Yes, sir.
I have lots of questions.
Yes, sir.
First, I go to the conclusion part.
Okay. Yes, sir.
You mentioned the graph. And then what is the x-axis and y-axis? How you compare the graph?
Actually, we have computed the graph with that particular simulation time was there. I have just maintained a graph with 310 minutes and 96 minutes, and according to that, we have just created this
310 minutes. Where is 310 minutes means what? We are working for the second, not for minutes.
Yes, sir.
I think. And then you mentioned that it's a 350 minute, right?
Yes, sir. Can you repeat it? What you were saying, I'm not getting.
What is the x-axis and y-axis in the graph? How you compare the AlexNet?
Actually, this is for AlexNet and this is for GoogleNet, and this is the total simulation time was there. And with this
simulation time from 0 to 350.
Yes, sir.
Then what is the x-axis?
X-axis means in this way, this two network was there, and this is the total simulation time with this y-axis.
This is not a graph, sir. We have to mention that x-axis and y-axis already. Okay.
Okay, sir.
In this way, you are not going to compare any graph without mentioning the x-axis and y-axis. Okay. Second thing, what is the difference between AlexNet and GoogleNet? Can you elaborate that?
AlexNet and GoogleNet, those pre-trained CNN, but the corresponding network structure was different. in AlexNet, the have much lesser number of stages in between stages than GoogleNet.
How you compare that AlexNet and GoogleNet? In which parameter you would consider that AlexNet is much faster than GoogleNet?
We have only taken into the consideration the simulation time.
It's not like a simulation time. When the data size increases, how you mention that AlexNet is much faster than GoogleNet?
Actually, sir, we have given the same training data and the learning data was also same. So if all the other parameters are same, and it has also
but as per your graph, you just mentioned that AlexNet is very smaller. GoogleNet is very smaller than AlexNet, right?
yes,
AlexNet is taking much lesser time as compared to the GoogleNet, but
yes,
it's
sir.
not in practical manner.
Okay, sir. Okay,
Yes,
sir. I will improve it.
because you just mentioned the graph only, right?
Okay, sir. I will.
Second, what is the difference between machine learning and transfer learning? Why you use
Machine,
transfer learning in place of machine learning or deep learning?
so machine learning and deep learning, sir, actually, if we are using the a single stage network, but in case of deep learning, if convolutional neural network, that is multi-stage networks, when it will be used, then that will be called as deep learning. And here, AlexNet and GoogleNet both have multiple stages are there. That is, there are so many hidden layers. Stage means there are so many hidden layers were
Where
there.
where is the hidden layer in GoogleNet, right?
Yes, yes,
Yes, if the number of hidden layers is there in GoogleNet, then it's increase the security, right? Because
obviously.
then
So if we are
it means the GoogleNet is much more secure as compared to the AlexNet.
obviously, sir,
Then
GoogleNet,
then but
yes,
you consider only one parameter, only time parameter. In that basis, you mention that AlexNet is much faster than GoogleNet. But in reality, it's not happened
okay, sir.
because you have to compare different parameters in different consideration.
Okay, sir.
Yes.
Thank you, Dr. Thank you, Dr. Kumar. However, we have many papers we presented. So
Yes,
that
yes, sir.
thank you for the yes, yeah, okay. I think that in this paper you should present more detail about how about your method and how about your experiment. However, in this slide I see that you not detail. However, if audience have any question, please contact with the author later. Now, Kumar, Dr. Kumar, please introduce the next paper. Sorry, Dr. Kumar, do you hear me?
Yes, please continue for a second.
Okay. Please
So,
introduce the next paper.
sir, thank you very much. So, today is it over for my present? Is my
Yes, yes,
presentation?
yes, yes. Yes.
Okay, 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 sir. Okay, sir.
Okay, let's welcome the author of the paper. Facial expression recognition system using FPGA based convolutional neural network from Thanh Nguyễn Dương Phúc, Nam Nguyễn Nhật and Nguyễn Linh and Ninh Trần. Now, welcome. Anh cấp quyền cho.
Good morning, ladies and gentlemen.
Professor.
Good morning, ladies and gentlemen. I'm Thanh.
It's okay. We present your research.
Hello?
Yeah, everyone hear you?
Can you hear me?
Yes, yes.
Okay. Good morning, ladies and gentlemen. I'm Thanh from Electrical Electronics Department in Ho Chi Minh City University of Technology. Today, I'm here to present to you about deep learning for intelligent system and my paper title is Facial Expression Recognition System using FPGA-based convolutional neural network. Okay. My speech is divided into 5 parts. I will start with abstract and introduction, then moving forward to robust work, architecture and experiment of network, and finally I will look at result and conclusion. Let's start with some general information about emotion detection. It has become one of the most significant aspects to consider in any project related to affective computing. There have been plenty of methods applying CNN model and conducting in software. However, traditional software-based computation is not fast enough to meet the demand of real-time image processing. Therefore, we propose an efficient method for expression recognition using FPGA-based. Introduction: emotion recognition is necessary in many practical sectors. CNN is a modern and efficient algorithm for computer vision. The CNN algorithm of this recognition system must have high reliability, appropriate in tasks requiring the accuracy. In this result, we present an architecture implemented on FPGA using hardware description language Verilog. Secondly, I will talk about dataset preparation. In dataset FER 2013, there are 2 points should be noted that result in errors in expression detection algorithm. One of them is that the number of images belonging to expression 3 happy is far greater than to belonging to expression 1 fear and expression 2 enriched. Well, I have told you about robust work. Therefore, in order to improve reliability in result, we will optimize the dataset by balancing dataset FER 2013, reducing up image of expression 3 and merging expression 1 and expression 2 together before training. Next, I will look at performance of convolutional neural network architecture. My network is trained for 200 each-block. The accuracy about 65%. It is proceeded neural network training of Google Collaboratory Workstation. Take a look at it. Now we will move experiment the column image by firstly which is facial image for experiment. We use MATLAB tool to work face part and design it to 48 48. Once getting facial is made in grayscale, we turn it into single floating point. Third, 32 big from. Then we have big stream input ready for simulating by hardware description language. FPGA architecture. In this session, we describe in detail the designs of input, output, and IP core CNN. We connect design IP core for other convolution of one reflection linear unit 1 pooling 1 convolution 2 reflection linear unit 2 pooling 2 convolution 3 reflection linear unit 3 pooling 3 convolution 4 reflection linear unit 4 pooling 4 and fully connect 1 when fully connect 2. Look at it. The top module of CNN IP core has 6 input ports and 2 output ports. Let me turn now to result and conclusion. This picture shows you my result simulation with clock frequency 200 MHz and signal peer output after 2.404 seconds. Now just to summarize, let's quickly look at the main point again. In original purpose, we decided to simulate this architecture on hardware where trade-off between accuracy and result are concerned. Therefore, our next target is to improve the system by applying fixed-point data type and only implement 2 convolutional layers on hardware. The other layers will be implemented on software in order to reduce FPGA resource consumption. Thank you all for listening. It's a pleasure being here today. Now I'll try to answer any question you may have. Thank you.
Professor Tai? Hello? Hello?
Thank you.
Hello?
Yes, Professor, how you calculate the accuracy of your work? Because you mentioned that it's 65% accurate as compared to the other work. How you calculate the accuracy?
Okay, thank you for your attention. I have 2 questions. The question 1 is why you choose 4 layers in your model? And the question 2, how do you set parameter in your model?
Professor Tai, are you there?
Mr. Raghvendra, do you hear me? Mr. Raghvendra.
Hello.
Hello, Mr. Raghvendra. Do you hear? I had 2 questions for your presentation. The first question is why you choose your model with the 4 layers? Now we will Dr. Kumar, please introduce the next presentation.
Hello.
Yes, please introduce the next presentation.
Yeah. Please introduce third presentation. Okay.
Next presentation is from the the research paper. Friction is present in the connection with CNN and MSTLN. Now, welcome, Mr. Lane.
Okay. Hello.
Please continue.
Okay. Yes.
Okay. Good morning, everyone.
Good morning.
Today, we would like to introduce the method to recognize facial expression with CNN MSTM. We are from the Data Analytics and Artificial Intelligence Laboratory, Engineering Technology Faculty thuộc Dòng Một University. I would like to introduce the content of our presentation. First, the introduction of our research. The second part is related work, explaining touch of how we study the previous research. Next is our robust methods. The fourth step is conducting the experiment. And the final is our conclusion in terms of this research. Computer vision is a type of AI. In computer vision, there are many problems. For example, interaction, static event, object recognition, and motion estimation. And so facial expression recognition is a part of computer vision. In our life, emotions are reflected in voice, hand, and body gesture, and mainly through facial expression. We are human beings express emotion in day-to-day interaction. Understanding emotions and knowing how to react to people's expressions really enrich the interaction. In 1992, X-Man et al. Has divided facial expression into 6 types: disgust, anger, sadness, happiness, fear, and surprise. However, the research report by Alex and Martinez show that there are 22 composed facial expression of emotions. In the past, the traditional methods for recognizing facial expression were local boundary bottom, non-negative matrix facial presentation, histogram of oriented radius, by learning with traditional classification method, SVM, Bayes, LDA, and more advanced method is deep neural networks. So years ago, there have been many research and solutions about facial expression recognition. Here are the related research. First is the research face description with local binary pattern application to face recognition of Honan and RO. Jimmy et al. Also investigate about facial expression recognition based on local vision specified feature and support vector machine. And Deme et al. Investigate about emotion recognition used that meet display how features. And the research face expression recognition with a two-channel convolutional neural network by Hemester et al. Yeah. So our solution is to combine the several features of CNN model and MSTM model. In that CNN model is used to extract features while MSTM recognize facial expression. The experiment is conducted with CAFFE database and is evaluated by accuracy and confusion matrix costs. The method that we support is consist of two main parts: hybrid deep learning method, CNN STM, and facial expression recognition. Convolutional neural network was proposed by Kunihiko Fukushima in 1980 and was improved by Lechem, Botto, Benzo, and Hefner in 1998. During the process, the image is processed through the main layers, including convolution, Boolean, and fully connected, and the final result is the feature of original estimate. Sample, starting with convolution layer, we have a nice image and a tree kernel. After kernel is scanned through original estimate with calculation convolution, we get a 177 image as a smaller scale with similar features. Next is Boolean layer. We use a two Boolean windows to scan the result of convolution by using math Boolean, and the new result has basic feature of original estimate. Rectified linear units is used widely recently due to its simplicity. It helps to keep values greater than 0 and max negative value is equal 0. This weakens the training of some deep networks. After the original estimate has gone through many convolution and Boolean layers, we have collected on of these features. Then we use some future fully connected layers to compile the feature into output model. So our robot method includes two convolution layers and two Boolean layers and two fully connected layers. LSTM was renovated from INN. If INN use one gate, then LSTM use 4 gates. Due to the 4 gates, we can memorize forget type of result from review step for the next steps. So our subject method is hybrid deep learning CNN LSTM approach. The CNN is effective in image classification to extract features, while LSTM has produced remarkable result to process sequences of inputs for facial expression recognition. With the vectors learned from the CNN LSTM model, the output layer is defined as shown on slide. By minimizing the mean square error between the predicted facial expression loss and actual facial expression loss, the hybrid CNN LSTM model is trained. The plot function is defined as follows. In this experiment, we use Japanese facial expression CAFFE database, which has 215 images of 10 different female models posing for 7 emotions. We conducted an augmentation of the dataset following the robust method by Quigley et al. After the augmentation, we can generate 13 samples for each original image in the dataset. We used 5 rows validation in our experiment. We have done experiment with the library, K-Rust library, TensorFlow backend, and OpenCV. We evaluate the accuracy by this formula, where TV is the true facial expression recognition, and FP is the font facial expression recognition. The accuracy percentage we get from the CNN LSD model is better than CNN model. The results show that the accuracy rate is significantly high as 86.42%. The error rate is that. This is a confusion machine scored with only deep learning CNN model. And this is a confusion machine scored with hybrid deep learning CNN models. Hybrid deep learning CNN LSD model, sorry. This is the facial expression estimation of CNN model. And this is a facial expression estimation of CNN LSD model. So in conclusion, when it comes to solution, we use hybrid deep learning method by combining the superior feature of CNN and LSD model to recognize facial expression. In this solution, each extract features by using convolutional neural network and recognize facial expression by long short-term memory. During the research, we conduct experiment on CAFFE database and evaluate by accuracy and confusion machine code. After completing the research, we will focus on training the network with more data, more filter, and more depth to improve the accuracy in facial expression recognition. Thank you for listening.
Where is Mr. Kumar? Kumar? Dr. Kumar? Yeah. Dr. Kumar, really conduct this section for me. Okay, thank you for your attention. Anyone will have any question for this presentation? No question. Dr. Kumar, do you have any question? Okay, if you don't have any question, we will move to the next section, next paper. Please welcome the author with the title Checking Control of Parallel Robot Manipulator using RTF Neural Network. Please welcome Vũ Lê Kim and Nguyễn Đình Dũng.
Can you hear me?
Yes.
Okay.
Good morning, ladies and gentlemen. I am Vũ Lê Vi, come from the Faculty of Mechanical Engineering and Mechatronics of Technical University. Now I would like to present our study with the title as Checking Control of Parallel Robot Manipulator using RPF Neural Network. Nowadays, parallel robots are used more and more popular in industry.
Sorry, Mr. Vũ Lê, please show your slide. We don't see your slide.
Sorry.
You should share your screen.
Okay. Can you see my slide?
No, not this. Okay, now this last slide.
Okay.
Because of the line compact structure, high rigidity and accuracy, data robot is a kind of successful parallel robots. 1,000 of inventions have been created in over the world for application in the packaging industry, medical and pharmaceutical industry. In most of the application, robots must move as fast as possible from the current position to another position or follow a given trajectory with high accuracy. However, for the case of parallel robots, there are only some studies about problem reported recently. On the other hand, the robot law as PT, PID, or CTC are simple, but they are not effective because of the parameter dynamic model of the robots required to be known exactly. Sliding mode control is a control method with high stability and to be applied in many researchers in the robot controlling products. A main disadvantage of the sliding mode control is oscillation around a sliding plate where both the load and frequency are not determined. In the paper, a checking control method based on sliding mode control law for robots following the given trajectory is presented, where the radial basis function neural network is applied in approximating the indeterminate item of the parallel robot. The numerical simulation of a specific roster of data robot is performed in order to stability of this method with the uncertainty of the robot model. The design of a roster of data robot is shown as a figure. There are three activities corresponding to the three translational driver source. And they are created to the mobile platform, the parallelogram list. By using the parallelogram list, the mobile platform is always horizontal. For the purpose of estimating the movement equation of the mechanics model of the parallelogram list are here replaced with the linking paths where the last is set. mechanism model observably illustrated as in the figures. The three parallelogram links observables are equivalently replaced with the same link at a rigid bar. From the mechanism model, the position of the drive links is determined by the parameters. The position 2 and 3 of the links is determined by the angle Q and C, and the position of the mobile platform is determined by the coordinate of its center points. The reader generalize the coordinate used for establishment of the movement equation of the robot is as shown by equation 1. By applying the form of Lagrange multiplier equation, the movement of equation of the robot are established as equation 2 and 3. The movement equation of the parallel robots can be rewritten in the general form as equation system 2 and 3. They are used for control method of parallel robots based on the sliding mode control law using neural network by dividing as equation 4, where phi A and phi Z are the differential of the vector contain equation to Q A and Z. By multiplying both the two sides of the equation to the transpose of S and replacing S naught and S dot, the movement equation is obtained at equation 5. The neural network structure is shown in equation 6, where Wi is the vector of the matrix W. In which W is JE weight for collecting the hidden neuron layer and the output of the approximate neural network. Sigma is the impact function. It is research an artificial neural network is selected to be radio basic function neural network, where its structure is shown in this figure. This structure has been mentioned a nonlinear function as the intended accuracy could be performed with the finite neural network. The control law U and the learning neural network are stated at equation 7. The control problem is an imperative that finding the control law U with learning neural network W I instructed way that the sliding plane come to 0 and the error also come to 0. The stability of the control method is improved by applying the envelope direct method about asymptotic stability, where a positive identification function is rated as equation 9, and its derivative is shown in equation 10. Because epsilon is smaller than epsilon 0, then derivative of v is negative with all the value of v without 0, and the derivative of v is 0 if v is 0. In the envelope direct method about the asymptotic stability is known that we come to 0 when t is infinity. Therefore, it concludes that the error comes to 0. From the robot model of the control law presented above, the simulation diagram for the parallel robot control is established as shown in this figure. The values of the robot parameter and its trajectory are selected as shown here, and the control parameters are given as shown here. Two cases are selected in this paper. That the first one is accurate robot without noise, and the second one is the robot with error and noise with the operating process. So numerical simulation for the control program of the program robot by using the software MATLAB Simulate. For the first case, the figures present the simulation results of checking error for the position error of the active source and the center point of the mobile platform, where the accessor and the audience present the time and the errors, respectively. The control method based on the sliding control node using with the neural network gives us the position error of the center point of the mobile platform to be about 10 power to minus 5 meters. In the case of both the robot dynamics parameters to be known exactly. In the second case, the error and noise are given iteratively as equation element. The simulation results of checking error for the position error of the active source and the central point of the mobile platform are shown in the figures. The plot shows that the checking errors go to approximation of 0 after about 0.2 seconds. When the robot dynamic parameters meet the error to be about 20% and there is a noise of forces in the operation, the error of the center point of the mobile platform is about 10 power to minus 4 meters. This error is acceptable. So the conclusion of this paper is that this paper used RPF neural network to compensate the certain nonlinear items in the dynamic model of the Rostov Delta robot in order to improve the control quality. The stability of the checking error was proved by applying Neapolita's direct method about asymptotic stability. The simulation results of checking error also shows the stability. However, it is still necessary to perform the comparison of the simulation result to the experimental results in the future in order to consolidate this control method. The comparison of the numerical simulation results and the experiment is necessary to be performed in the future to verify the result in this study. My presentation is finished here. Thank you for your attention.
Okay, thank you for your attention. Do you have any question? Okay, I have two questions for you. The first question is why you choose neural network for this study? And the second question is, do you have any experiment with when you compare your result with other?
Yes, thank you for your question. For the first question, we choose neural network because it's the most accuracy when we compare to other methods, and it's also easy to implement for the control robot.
Mm-hmm.
And for the question, the second question, at the moment we hasn't got any experiments, so we do the experiment for comparison in the future. At the moment, we have only simulation results only.
Okay. Thank you for the interesting presentation.
Screenshot भेजा हूँ मैं आपको download के बाद.
Yes.
Hello.
And,
Hello.
Yeah.
Anyone
Hello.
have
Hello.
any
I have a
question?
question.
Yes, please.
Yeah, Dr. Kumar.
What is RPF neutron network? What does it mean?
PRF is the it stand for it is um, it is stand for region basis function. So
Sorry, I'm unable to
RPF.
get you. Yeah, RPF neutron network. What is meaning of neutron network? And what is neural network?
Yes, the neural network is extended by apply radio basis function. So the method is now called RPF neural network.
In place of neural network, you use a neutron network. Then what is the difference between neutron and neural? Because a neutron is also come under neural network, right?
Yeah.
Then why you
Yeah,
mentioned that it's a neutron network? Can you
Um,
please elaborate this?
Okay, I think I need read more document to explain that for that question. So so you can send me email. I would like to answer last question through via
Okay,
email.
okay, no issue, no issue.
Yeah.
Thank you.
Okay. And please welcome the presentation with the title an IoT-based air quality monitoring with a deep learning model system. Welcome Hasi Srivastava, Kailas Bansa, Santos Kumadas, and Santanunka Saka. Who will present in this presentation? Kailas Basa will present. Okay, welcome.
Hello. Good morning, sir.
Yes.
I am able to hear, sir.
Yes. Please continue.
Okay, sir. Thank you, sir. First of all, good morning to everyone present here and all other authors present in the session. I am Kailash Bansal. just completed my MTech from Department of Electronic and Communication Engineering in National Institute of Technology, Rourkela. My paper presentation is on the topic entitled as an IoT-based air quality monitoring with deep learning model system. One second, sir. Actually, the flow of my content of my presentation will proceed as follows, starting from introduction, motivation and objectives, problem statement and challenge, proposed system, TL based and LSTM model, then final result and discussion with concluding and future scope. First of all, as we are proceeding toward the development of smart city, the biggest issue is the deterioration of environment condition while proceeding in the development of the smart city with different technologies. So air pollution is the major concern in our city, where the undesired presence of impurities rises in the proportion of different constituents like CO2, SO2 due to different factories and activities like vehicular activity in the city, which are visible or invisible. So suspended particles are also there, which has their long term and short term both effects, which are temporary and permanent, like it causes dizziness, headache, irritation, and long term effect also like that it has an adverse effect of kidney, liver, etc. So in this case, when we are proceeding toward the smart city, so it is also a major concern in our to see regarding this, to combat this problem. So an IoT based pollution monitoring with prediction and forecasting platform is the best effective solution for that. And the application which can be used for in different smart cities by CPC, Central Pollution Control Board, State Pollution Control Board, and other private government agencies, etc. So what are the motivation behind this research work or project which I have done? There are lack of methods for analyzing the air quality monitoring based on prediction forecasting model system. And the primary object is to develop a model based on the deep learning algorithm. Specifically, I used it, we have used is RNN, means recurrent neural network based on long short-term memory model for time series forecasting the air pollution. Also, the industrial areas like mining sector, in mining sector, they are required to monitor the air pollutant matters, suspended parameters. So the real time air pollutants and weather parameters are being monitored, and it can be stored in a cloud server where we can use Firebase or other open Google cloud server, which can be used for forecasting it. Next, the problem statement and the challenges behind the doing this project or research work is: first, the real-time air pollutant with the weather parameters we have to sense should be stored in the database for various application. And the challenge is to get the accurate value for which calibration is done. Calibration is required for the sensor, because the sensor which we use, whether the high quality also, which require calibration. Some are pre-calibrated also available, but calibration provided which make the sensor to take the real-time value in the more accurate value. Second, the large data set is because we are using for time series forecasting model using deep learning model, and in deep learning we know that large data set is required for that. So the large data set are required for the preparing the model system by analyzing the training and dividing into the training and testing data set using deep learning algorithm. System architecture model. First of all, what we proceed from the our architecture model, which is based on 4-layer system: sensing layer system, after that network, and then processing layer and application layer. It is based on 4 architecture layer model system, in which we have sensing layer, in which we are using the different sensors for prediction model like CO2, NS3, and other like temperature, humidity, and dew point parameters. For processing, we are using based on IoT technology, and we are using Raspberry Pi as a processing unit over it. And because the some sensors give analog values, so we have to use analog to digital converter, high precision. We are using analog to digital converter to convert into digital form, so that Raspberry Pi can process the data to get the value at the output. Power supply, and then the data is fed to the cloud server, where we have used the Firebase and open Google server database. After that, we can use for the various applications, like for prediction model, the data set we obtained, are used in the system model. The flow chart of diagram of the proposed system, the flow of work is going as follows. Like, first we have to connect all the device network, what we assembling all the devices, sensor, processing unit, and with the network. After that, we have to read and process the sensor value, which we have to send to the cloud server, and there whatever with the data sets we get in the large amount of data, that is used for prediction based on deep learning. And that predicted value we are used for reading, and you can use display on the web on Android app as follows. Actually, because we are using different sensors, So we are following the CPCB Center Pollution Control Board AQI calculation approach value, where we are using this AQI calculation formula, which we have obtained the different air pollutants value. So we have calculated the AQI based on this formula, where we first calculate the sub-index value for each air pollutant, aggregate them with some weight factor, and finally we propose this we are getting, in which I is denoted by the AQI value corresponding to breakover point of high value and low value, because as BHI and BLO are given by the CPCB parameters already, it is specified by the CPCB, and CP is CP is denoted the means current value which we are getting. So we have to calculate from there AQI. Then finally we can aggregate all the values we have obtained by as denoted by II. As we have used in the weather parameters to monitor dew point, means temperature, humidity, and humidity and dew point. Dew point is calculated as per by August-Rose-Mangus approximation, which is given by this formula. Wind speed, for which we have used anemometer, which gives analog output. So to calculate our wind speed, which is in meter per second, so this formula is we have calculated by as per the data sets it is obtained. This is the air quality chart. As we follow the air quality chart, that which range the AQI values, that lesser the index value, it is good for for the environment or for the surroundings also. Like that, this AQI chart is, as just mentioned. As what we are getting the different output of value. So we have used the cloud server, that is Firebase database, in which we have we store the data is stored in the form of packets like that. In each span of time, whatever the data is coming for each span of time, it is stored in the Firebase. That one image I have shown here, that we have used in the real-time value to store the data in our database to use as a data set for the prediction value. That is our main motive for the model system to prepare. First of all, and now the main thing which we have used, that is deep learning model system. As deep learning model system is a technique in which we use the large data set for predict time, using the time series forecasting model system preparing. In which what we have this is the flow chart, means I have prepared, but in which what we do, we first whatever the data set we have stored in the cloud server, we have to load that data and scale the data. And after that, that data set we have to prepare for learning, in which we split the data into training and testing or validation data sets, and creating and algorithm. Creating and train the model by using LSTM model, and after that we get the forecasting the test data and calculating the loss function over that. We have used here RNN LSTM model system. What is RNN system? This is the cell we have. I didn't specify the image. RNN is the recurrent neural network. It is an algorithm technique in which the data set, the data at the output from the previous layer is fed back to the current layer to train the model, so that the accuracy can be increased, which is based on the back propagation technique. Hello, excuse me, sir.
Yes.
Sir, actually disconnected, some problem. What I am.
Yeah. We don't see your slide now.
Sir, not properly. Actually, 1 second. I can continue, sir.
Yes.
Okay, sir. Okay, sir. Sorry, sir.
Yes, Professor Kerala, please continue.
Yes, sir. Yes, sir. I'm continuing. So I was telling about the RN network. So it is based on the backpropagation technique in which the cell is used, and why LSTM model in that RN system we are using. Why alone RNN is not used? Because alone RNN model using algorithm using is that it has the disadvantage that it has the short term memory. That is the from the data, as we use the large data set. So most of the important information can be skipped from the starting of the data set, as it has a short term memory. So for that to combat this problem, we are using the long term memory, in which there is I will show the procedure. This is the procedure in how RNN model process this. So in RNN model, as there are different large number of hidden states we use in the sequence, so there are in between we are using the LSTM model, in which there is a we use the three in LSTM cell there is a inner gate, forget gate and output gate. So first of all, what we use the data set which we have divided into 10 these are used as converted into vector form, and it is multiplied it is passed to the 10h activation hyperbolic 10h activation function, and which is used as the new memory. And this activation helps to regulate the values between -1 and 1 to flow through the network. After that, the LSTM decide which information is to keep or which can be skipped if it is not important for the cell step for training. So gate contains the sigmoid activation function. Sigmoid activation function is also a non-linear activation function which regulates the value between 0 and 1, which help to the data to update or forget the data using forget gate. To update the cell, there is an input gate on which the output obtained from the 10h activation function is multiplied with the sigmoid activation function, and then the cell state obtained after that is pointwise multiplied with the forget factor, and the pointwise and the addition of the output from the input gate is updated to the cell state for the new value to which is helpful for the training in the neural network. And after that, the last stage is the output gate, in which the cell state decide that what is the next hidden set which will be used for the prediction. Then the modified cell state is passed again to the 10h activation function in the starting from the input gate, and this process continues in the LSTM model to increase the accuracy level by taking the feedback of the different outputs which we have obtained, so that the training can be used for the system. These are the data set I use with already we have discussed. This is the I taken the image in which pollution we have calculated dew point, wind speed, and this rescale parameter as obtained from the algorithm. Forecasting, and this is the forecasting model on the left side of pollution, dew point, and based on the algorithm which we have obtained. Data set used, and the loss obtained based on the epoch, means number of iteration. We have taken up to the 60 epoch function, in which as the number of epochs increases, the loss of the between the training and the validation decreases, and the difference between the both become less. So the loss is approximately about the 20 near about percentage which we can obtain. What is the advantage of using LSTM model? Already I said that why we are using LSTM model in RNN, that it has the long short-term memory advantage, in which we can use it will be advantage in taking the important information that can't be escaped from that, which is useful for the training the data, and the accuracy can be increased. So accuracy of the prediction also increased based on the backpropagation technique, as feedback is given to the current layer from the previous layer, which improve the accuracy level as the increases. So other application which can be used by this model also text generation and language modeling, etc. I then finally come to the conclusion part, that first of all, the development of proposed system with integrated Raspberry Pi processor, air quality, with based on IoT technology, The proposed model air pollution system based on how to monitor and analyze the time pollution and weather parameters. Real-time data is then stored using an open Google server database, that is Firebase. It can be retrieved for analyzing the obtained data, and the main aim is to deploying the deep learning based RNN LSTM model for prediction and forecasting time series air pollution data in real time. What is the future scope? We can proceed in this work based on that, predicting and analyzing this air pollution monitoring and air quality level using other deep learning techniques to compare the accuracy or loss value of the prediction. The user interface Android web application service which can be developed for real-time monitoring and add notification feature for individuals. And last, we can proceed in this routing algorithm which can be implemented for health-based application for individual by navigation through Google Maps for showing the path through based on the safe path in real time. Thank you for the attention, all of you, and any questions, sir? That's all from my side.
Hello.
Okay, thank you for your
Hello. Sir.
Yes, sir. Yes, sir.
I have one question. It's a application based or real time based, sir? What you did in this? You design it or something?
This is, yes, sir. We have actually in my system currently I used for real time application, means we have used our own system we have developed in the real time using the hardware module we have developed. Already I discussed about that Raspberry Pi processing sensors that we have used Figaro sensors, the best quality. So real time application, for that we have used the data set in the real time using.
How you capture the data from the real scenarios?
From the environment, sir, because we are using the sensors in our campus only we have used that module.
And after that, what you did?
After that, whatever the data we are obtaining, we are storing in the Firebase database in real time. I saw one the image of Firebase data that is stored in from our real time in our campus. That I already said in NIT, we have fetched the data from the environment using the different sensors for CO2 and S3, and that data is stored in the Firebase cloud server that I have said. Share one image I shared, in which in one packet it is storing one value for each weather parameters and this. So for each span of time it is storing the data, and that data stored we are obtained from as an Excel sheet. That data set that is .csv file we always get.
How you process that stored data in the cloud?
Pardon, sir, not understood.
How you process the data in a cloud environment? There is a use any algorithm or some model?
Actually, the Firebase database server, actually I have done the coding for monitoring the airport in Raspberry Pi uses the Python. It has its own operating system, Raspbian OS operating system, in which we use the Python programming to obtain the data or for fetching the data from the Raspberry Pi. So processing it. So in that we use the API key, and for the Firebase open database server is there. So we have to pass that authentication system to that Firebase data using API key, so that the data whatever we are fetching from the Raspberry Pi, it is directly sent to the Firebase database where it can be stored in the there.
This work is useful for the society or not? Can you tell me that?
Yes, sir. Actually,
how it's useful for the society?
Okay. Actually, how I
can you give any example?
Yes, sir. I can give one example. Actually, in the starting of January in India, means in our capital city, that is New Delhi, Lajpat Nagar, there Gautam means MP of government, they have installed one smoke tower in Delhi.
Okay.
So what we can use, that smoke tower is used for the cleaning the air. So it is fetching, it is using the cleaning the air continuously for whole day. So what we can do, we can apply this algorithm based. What is used for? It is used for prediction and forecasting the model. So whatever the data is coming, means cleaning, because it will get the data also, fetch the data. So we can use for the algorithm to fetch the data so that it can predict the future means next day what it will be the value, so that the system can be optimized to the best level, so that some power consumption because in our any system based on IoT we have to see many parameters like that power consumption problem, that it should power consumption not continuously running the system so that power is lost so much. So we can forecast the things, so that this is based on that when the air is more polluted, and these things we can implement it there to make the system more robust.
Yeah, but I had one suggestion. The first one suggestion to you, you should present more detail your data in your slide, but here we can see more detail in your slide. And I have one question to you. Could you show me your parameter in your model and why you choose this parameter?
Sir, sorry, actually I am not able to hear from that side. Noise is there, so
One again. One suggestion, you should present more detail about your data set. And one question to you: which parameter do you choose in your model, and why you choose this parameter?
sir, actually parameters you are actually the question can be repeated from other sir.
And something like that.
Professor Kailash, I am repeating the question from
yes sir.
side. He
Yes,
asking about which parameter you used and why you that parameter you chose. That is asking.
Okay, sir. The parameter which I have used is that time weather parameter, temperature, humidity, wind speed, because it is the necessary ways for weather forecasting also, that for forecasting with the temperature, wind speed, because these have the effect on the air pollutants also, that effect of temperature, so we can make infuse the effect of temperature. These can also be come into consideration. And the air pollutants which I have used is CO2 and NS3, means carbon dioxide and NS3 ammonia, which I have used for the actually the sensor we provided from the industry as I was proceeding in the project in the second year. So we get that sensors in the working, so the CO2 and NS3 were provided. So I guess because the main parameter also for air pollutants, as per the guidelines also AQI, there are 3-4 parameters we take into consideration, that NO2 also there, but I was not able to take that into consideration. But CO2 and NS3 the important parameter for air quality pollution monitoring, that we were able to take. So AQI, because AQI, for calculating the AQI also, there are different functional we can use for in the formula based on that CO2, NS3, SO2, NO2, like that. So whatever we get provided by the institute, so we were able to make that system in the consideration, and that's the parameter I used in the system, sir.
You used 2 parameters to calculate the air pollution, CO2 and NS3.
CO2 and NS3, sir.
But nowadays the number of gases is there in an environment. How do you use that gases to calculate your air pollution and all the things? Because
other parameters
are well-known gases, I think.
Yes, sir.
But we have to work in minor areas.
Yes.
Then it's very normal to calculate the CO2 and NS3.
Yes,
there is no need of I think IoT devices. It's already government have the database related to CO2 and NS3.
Yes, sir. There are various other system models already.
The government have data till 2017 in Indian government.
Yes, sir. I agree with you that there are different system model based on different air pollutants.
Yes,
the system model
has been also have different models to calculate the CO2 and NS3.
Yes.
Then why the model is more significant than compared to the other existing model?
Actually, when this was working, but now after that we were provided. Now actually at that time I've done this work and this paper I have submitted. That time also only I have got the 2 sensors available. So after that we have proceeded in this project, because this project is continuing right now also, because I already said that we are working in future
So
scope, that is on.
first listen to me. The CO2 and NS3 data already in government have all the data, right? Then the government no need of the IoT devices to calculate the air pollution and all the things. If we have already data, then what's the need of develop the IoT devices?
Yeah, thank you.
IoT devices is useful for the environment to take all the gases, all type of disturbance coming inside the environment.
Yeah, it's a nice.
Yeah, sir. Currently, the project.
You can say it's a funny question also. What is the difference between
for your presentation, and like we will move to the next presentation.
I am asking this
automate currency using
Actually, no, excuse me, sir, noise is coming so many. I'm not able to. I am not audible. I think.
So, Mr. Batra, please repeat the question.
Are you getting me?
Hello.
Yeah, sir.
Now, so.
Okay, thank you, Mr. Vansal.
What is the difference between the deep learning and machine learning?
We present in paper.
Yeah. Next, please continue with the next presentation.
Sir.
Okay, welcome.
Sorry, sir. I'm not able.
My question was something like that. Because same concept,
now it's over. Your presentation is over.
Demand forecasting.
Professor Vansal.
Already, this research article paper is already available. Okay, but here so far implemented with machine learning. Now I am having a funny question in my mind. What is the difference between machine learning and deep learning?
Okay, sir. Difference between machine learning and deep learning. Between machine learning and
it's over. Your presentation is over. Don't worry.
Thank you, sir.
In the presentation.
Hello, good morning, everyone.
Good morning, Professor.
Good morning. Am I audible?
Yeah. Please continue.
Yeah. Good morning, everyone. The present here, and thank you for being so patient and for inviting me for giving the presentation virtually.
You are Abhishek Jain, I think.
Yeah, my name is Abhishek Jain. I'm from Graphic Era Team to University, Dehradun, India.
Okay.
Well, I am here to present my paper, that is automated currency recognition using neural networks. So in this presentation, I'm going to present these topics: introduction, methodology, resultant discussion, applications, and its conclusion. So first, let's go through with the introduction. So as we all know that if we say about money, so money in the form of money, we use coins and the paper notes. And in the coins and the paper notes are the very best, because suppose if we have to pay someone 1,000 rupees, so we can't pay them in the form of coins because it will take so long. So the paper is the best. And so the idea of this paper comes into my mind when I see the ATM machines, the electronic vending machines for the tickets and the different things. So this is the idea of the paper. So if we suppose we need to get the cash from the ATM machines, so if there was not a system for the recognition of the paper, so how the machine will be able to give us the count of the money that we need. So this is the why I made this. And because if we don't have this, so the manual testing needs more time. So let's come to the methodology. In this I use the neural network. So neural network needs more images. So the data set I used, it has the total images of 3062 images, and there are total in this, I classified the images in between training images and the testing images. So the training images are 2516 and the testing images are 546. So in the training images and testing images, I use the different classes. So these are the classes, the 6 classes. The first one is the 10 rupee note, then second one is 20 rupee note, the third one is 50 rupee note, and fourth one is 100, fifth one is 200, and sixth one is 500. So these are the some sample images that are taken. These are just samples. I use the different angles in different lights, like a bright light, shadow, and different things. Like you can see in the 100 note, I use the multiple so that it can classify very very easily. So what I have done, first I prepared the training data set, which is prepared by myself by using my phone's camera and using different kinds of nodes. So then I used the testing data, and then I and then I passed my testing data into the training data, and based on that I prepared the confusion matrix. So the model which I used is this. First, the A part. In this, I just inputted my data set into the model. Then B and C. In this, the different features are get extracted in the convolution layer, so that it can be tested further. So after being tested and stored in the data, classification is done on the basis of that. So after the classification is done and the result are come, so I use for the classification I use 3 different methods. First is neural network, the KNN, and the SVN method, so that the classification I got is the best. So among 3 neural network, the KNN, and the SVN, the best accuracy that I got was of neural network. And the confusion matrix, you can see that I have provided the neural network uh, confusion matrix because its accuracy is high. Its accuracy is 97%, and method and the SVN method are also used. So the accuracy that I got in KNN method was 92%, and the SVN method was 96%. So the best accuracy among them was neural network. So I used the neural network and gave representation of this. Well, now it's time for its application. So there are different applications using that. The very first was in ATM machines. The second was RAM machines. It for applications. We can develop an application for, suppose from outside came to our country as a tourist, and he is not able to recognize that how much worth this paper money has is, is currently is. So it can be helpful for them so that they can easily identify the worth of that money. Now come to the conclusion. So in this paper we are able to classify the different Indian currency notes that we use, like 10, 20 different currencies, and we use the different classes like KNN and SQL, and among that the neural network gave the best accuracy. So we use the neural network, and its future scope is that we can make a classifier for the fake currency notes, and we can add different currency notes of other countries. Well, thank you. And sir, any questions from your side?
What is the research gap between existing work and full model?
Sorry, sir. I am not able to understand what your question is because there is so lot of.
What is your proposed model?
Sir, the proposed model is the recognition using the neural network.
Sorry.
Sir, the proposed model is that recognition of paper currency notes using the neural network.
Okay.
And,
Thank you.
How about your pre-processing? Those services, pre-processing with the data set.
Yes, sir. The preprocessing that I created the data set of different nodes like 10, 20, and different nodes up till 500. Then what I did, uh, I used different filters like multi-size filters, and based on that, I prepared my XML files and provide them into this. Sorry, again.
What and what kind of neural network? What kind of neural network model do you?
Sorry, sir.
My second question is what kind of neural network model
Sorry,
in
sir.
your business?
Hello. Sorry, sir.
You saw that you use the neural network, but I don't know what kind of neural model.
Sir, lot of echo is
Is it
there.
CNN?
Mr. Jain?
Yes, sir.
Hello? Abhishek?
Hello. Yes, sir.
हाँ ये बोल रहे हैं सर, ये बोल रहे हैं कि कौन सा डेटा सेट आपने यूज किया है और डेटा सेट का क्या पैरामीटर है?
Sir,
हेलो?
I prepared it myself. Hello.
Yes.
Hello.
Yes.
Sir, data set I used is being prepared by myself. I did not use any.
Then you are a data generator, I think.
Yes, sir. I use different kinds of nodes like 10, 20, 50, 100, 200, and 500, and I put them on table, and I used my personal camera, and I click different images around the 600 of each node, and in different angles and in different lightnings, so that a different kind of data is made and being used for the testing. So that,
From where you take your data set?
Sorry, sir. Sorry, sir. Hello.
How you generate the data set? Hello.
Sir, first I just clicked my different I just took different notes and clicked these photos, and then I pre-processed my data and then convert it to notes.
Okay. Thank you.
Thank you, sir.
Okay. Dr. Kumar,
please continue with the next presentation.
Okay, next presentation. Good morning, everyone. Today I would like to introduce our research with the title Vietnamese Named Entity Recognition using Bidirectional LSTM. We are from Data Analytics and Artificial Intelligence Laboratory, Engineering Technology Faculty of Suzhou University. Here is outline of my presentation. First, I will talk about introduction, next is some related work, and after I will discuss about our proposed method, and some explain when we and lastly, I will give information about our research. Now, let's begin with the part one introduction. As you know, LLP is taught in the AI, and there are many types in the LNP, natural language processing. And in the natural language processing, named entity recognition is the main type of other type. For example, in the document classifier, document summary, information retrieval, machine translation, and sentiment analysis. And you see that named entity recognition is the main type of other. Here's an example of named entity recognition. From the text, we will check what kind of named entity. For example, here we have the location, time, person, organization, money, percentage, and days. And for the named entity recognition, we can do by many ways. The first way is by supervised, and the second is semi-supervised or unsupervised. For supervised, we can use a method of work TF-IDF with the hand prefecture and machine learning approach. And the new approach, many researchers use work vector and deep learning approach for LSD, deep learning approach for named entity recognition, and this way give the better result than the other. Here is some related work with our research. For example, by the CIF, by 8VM or 8MM. For the Vietnam, we have some model, for example, NGN recurrent neural network, or Madison LOFM and CIF. And our solution is different with other. The first, we use the deep learning approach for Vietnamese named entity recognition, and we combine automatic syntax feature with rechain network embedding as input of deep learning model by directional STM. And we conducted experiment on VLSP 2016 dataset. Here is our proposed methods. From the document, we will extract the picture, and after that, we will get a vector picture. From that, we will give it to LSTM model to learning and predict the named entity for Vietnamese. In this research, we use work embedding. You know that work embedding from the approved by Mikolov in 2018 and work embedding. There are many ways for the work embedding. For example, SIBO or skip-and-rack. SIBO means that the continuous backup work. This model will predict from the present context by in the last couple column with a slide window. For example, here is SIBO. In this research, we use SIBO from the one operator of this work. We will get the every vector, and from that you can get the work together it work by using VChain many times to get the material. And in this research, we use VChain book embedding with the character embedding. From that, we get the book embedding for your model. And we use long short-term memory, and you know that long short-term memory is improved by recurrent neural network. It's a recurrent neural network is only one gate, and long short-term memory is 4 gate. With the 4 gate, we can forget or remember the last step or the last feature for the next feature on the step. For the next step. For example, if you focus on this gate at T, you can see that at T is combined from the last state with the feature of this. And in this research, we propose using bidirectional LSTM. Bidirectional LSTM means that we have 2 LSTM. The one in the forward and the one in backward. And from the forward and backward LSTM, we get the bidirectional LSTM. Here is the bi-LSTM in your model. You can see that from work embedding with the additional feature, we will get LSTM to forward and backward with the 2 by LSTM, and after that we use the stock layer, and from that we will predict the named entity. With the tech learned from the bidirectional LSTM model, the output layer defined by the Z formula, and by minimizing the mean square error between the predicted named entity and actual named entity, the bidirectional LSTM model is shaded, and the loss function is defined as follow formula. We do experiment with the dataset from the VLSP 2016 dataset. Here is more detail about the dataset. We define the interchaining, developing, and testing with a number of sentence in each dataset, as shown in this table. And we use tokenize and post stacking with the PIVI and chunking with LNTP. And we use the book vector pre-training with from the fast type of the Facebook AI research. We create for deep learning framework. Here's some parameter in your model with the bioestimate. The number of hidden nodes is 128. The active function is like a sigma, and we use the airport 500 Basrai 500 optimization function with ADA and the function with the category cross entropy. And we evaluate by the F1 score. F1 score is calculated by Z formula. We do experiment with the two by LSTM layer, with the one by STM layer and two by LSTM layer, and we see that the two by LSTM layer get better result than the one by LSTM layer. And we do experiment with some dropout with the dropout 0, dropout with 0.2, and dropout with 0.5, and we see that the dropout with the 0.2 get a bad result. And with the syntax picture, we calculate, we evaluate with the each picture. It only work and work to vector as with the post picture, and here they work with the child picture. And with the multi-vector with all syntactic feature, we get the bad result and at one score. And we just present about our research. In the research, we propose to use deep learning approach for Vietnamese named and easy recognition. We combine automatic syntax feature with pre-training work embedding as input of deep learning model by LSTM. And we conduct experiment on VLSP 2016 dataset. In the future work, we will change in large data and apply the result to other type of natural language processing. Thank you for your attention. Do you have any questions? Do you have any question with the presentation? Dr. Kumar?
Yes, Professor.
Yeah, do you have any question?
Sorry?
Do you have any question with my presentation?
Yes. I have one question. You use this model for the Vietnamese people only, right? Your work is only considered for the Vietnamese peoples, or Vietnamese language. Your work is related to the Vietnam peoples. But there is any code model which is used to.
What do you mean?
Any proposed model, proposed work, your proposed work, where is your proposed model?
Yes, indeed, we use some picture here. You can see location.
From where you get the VLSP dataset?
Yeah, VLSP dataset is from
where you get all the dataset?
Yeah. VLSP dataset.
How you generate the dataset?
It's contact for Vietnamese name entity recognition.
Sorry? Vietnamese repository.
Yeah, it's from the Vietnamese language association.
Okay.
And it's public for everyone.
It's anyone can access the dataset.
Yeah. But you have to submit the form and you will get the data set soon.
Okay. Then after the data set, you train the data, right? By using the which algorithm you use to train the data set?
Yeah.
Can you mention the algorithm or concept? How you train the data set?
In this research, we apply for the vitamin named entity recognition. And in this data set, they divide it to the four kind of named entity: person, organization, location, and listener.
Then what is your future work? Future work.
Yes, okay. Maybe we will move to the next presentation.
Sorry?
Sorry? I can't hear you. Maybe something wrong.
Okay, please continue with the next presentation.
Okay. Thank you. Yes, and my presentation. Good morning, everyone. Like presentation, I would like to present with you with the research with the title "Trade Decommission Using Hybrid AOG CNN Approach." And here is the outline of my presentation. You know that the file is very important in many applications, in many, let's say, for security, for recreation, and many that in our life. And now file decommission is very famous. To file decommission, we have the process here. First, we have detection, and next alignment, and lastly decommission. And with the traditional method, they use the handcraft feature with the standard learning, for example, FEM or BIS or something like that. And they use the local binary pattern or history of Orient variant. And in the modern research, they use the deep neural network and deep neural network as the material compared with the traditional methods. Here is some research related with our research. Defined recognition by part 3, yet multi-convolution neural network. And in this research, we propose hybrid method by combining of AOG and CNN. Why you propose hybrid method by combining of AOG and CNN? Because you see that we use the time is very important when we review application, and that's why AOG there's a good time when combined with the CNN. That's why we combine of AOG and CNN for this research. And the fail detection, we propose the NOG feature and FBM linear classifier. And the fail conditional is posed by CNN, by the failness. And we conduct experiment on dataset F, 3 dataset, and evaluate by accuracy in F1 star. Here your proposed approach from the data. We use the file detection by NOG and FEM, and we alignment, and last we do file declaration by CNN with the fairness framework. And you know about CNN is a framework model for the email process, email declaration. With the many layer here is the convolution. Convolution means that we will get a small picture, but small picture keeps the picture of the last picture, and so that with a small picture we can easily to process. And pooling, there are many kind of pooling, and in this the usually mark pooling is a good way for the pooling. For example, you can see that in here we use the kernel with the 2, and from the area we see that is mark pooling mark value it is 1, and likely mark in the like and that we get the small picture with the 4 side. In the file detection, we use the HOG and SBM linear classifier. The first picture we use the normalized normal encounter and calculate gradient and divide the group characteristic at each frame. After we will get the standard gradation and we check picture on the window and use the FBM linear classifier to detect the file or no file in this picture. And in the file recognition, we use the FileNet proposed by the Google 2015. Here the architecture of FileNet with the bar deep architecture and L2 and embedding with the chipless loss. We do experiment in 3 dataset FEI dataset, LFW dataset, and UOF. We do experiment with the Keras library, TensorFlow backend, OpenCV, Skitlearn, and NumPy with the and for file detection evolution, we use precision beacon and one score to evaluate in the file detection. You know that in the file detection we propose by HOG and FBM, and we get the result with the data set here and the result with the your proposed HOG FBM with the other adapter. And we see that the HOG and FBM get better result than the half. And for the file recognition, we use the accuracy to evaluate your result. Here is the formula for accuracy. And the result we get with the data set, and we compare with the PCA again file. And we see that the HOG and CNN get a better result than the PCA again file with their own data set. And in this result, we propose hybrid method by combining of HOG and CNN. The HOG and FBM linear classifier for the file detection, and file recognition model is the proposed based on CNN FaceNet. And we conducted experiment on the 3 data set and evaluate by accuracy and F1 score. And we see that your proposal will achieve a high and stable accuracy in the actual environment. And in the future, we will apply this result for the real application. Thank you for your attention. Do you have any question?
Professor?
Yes.
Hello.
Yes.
I have one question. You use the hybrid approach, SVM and HOG, right?
Yeah. Yes.
Then what is the difference between HOG and SVM and SVM and HOG?
Able to see your presentation.
Yeah. You see here in the detection we use the HOG and FBM, and in the reconciliation we use the FileNet.
Sorry? You did any experimental analysis for calculating the SVM separately, HOG separately, and combination of SVM and HOG? You did any experimentation?
Yes. And we compare.
Where is it?
Yes, kindly share your presentation
with the HANA line in this step. And in the file recognition, and we compare HOG signal with the PCI again file.
I'm talking about that you use the SVM and HOG as a hybrid approach. Then what is the difference between hybrid approach and SVM and HOG?
Yeah, because you know that in the time is very important. we use the ring application. For example, for the email recognition, if the term is the host is not useful, and that's why we propose
Are you
AOG
saying that it's
the
not
first step.
useful? SVM is not useful?
No, no.
There is
Yeah.
any mathematical model to prove that?
In this step, we only use AOG and FEM to detect file or no file.
I'm talking about you use the hog with SVM. Yeah. In three different data sets, right? My question is, we use the SVM separately in three different data sets and hog separately in three different data sets. Then after that, you compare the hog, SVM, and SVM plus hog.
Yes.
Yes, but in your paper you mentioned that it's hog plus CNN.
But in this step, we only focus on file detection, and for file recognition, we use the file name.
But you have an experimental proof that the hybrid approach is more efficient or more accurate as compared to the other existing algorithm. Directly you use the SVM plus hog, it's not a more accurate. You have to compare with the basic like hog first column, then SVM second column, then hog plus SVM in third column, then after that hog plus CNN. That is more accurate to understand the readers what is you are doing. Okay, but you simply use the all hybrid approach in three different data sets. I think it's not good.
Okay, I understand.
Because you have to compare with the basic and references are also missing in your slides. References are also missing. How you say how we say that our model is more accurate as compared to the other models? There is any proof?
In the future book, we should apply all CNN in your own step from the detection and recognition. However, if you use the CNN for
you want to use a recommendation system, right? What do you want to use?
However, if you use CNN for all process, the time is on all, and it's one problem. Because in the CNN is good in the long term compared with the SOG and FVM.
You simply detect an alignment and recognition of the data, right? Is image data.
Yes.
But my question is how you calculate, how you propose the model like hybrid approach. There is any mathematical background for this algorithm?
In the ring camera, if you use CNN for the whole process, the time is much more time. If you only use the FVM and SOG. That's why in this step we propose SOG and FVM classified in this step.
I understand your opinion, but my question is how you use the SVM plus hog. There is any background mathematical model?
Yes, okay. Thank you for the suggestion.
You have to compare from the basic to the higher level, na? Not directly you simply write the SVM plus hog or SVM plus CNN.
Okay, I got it. Okay, thank you.
Okay.
Yes. Please introduce the next presentation.
Yeah, please continue with the next presentation.
Yeah, you. Okay. Next, please welcome Vũ Điền Hồng and Lê Anh Cường with the research paper topic guide RNN models of dynamic text generation. Please welcome Vũ Điền Hồng. Không có. we will move to next presentation. Flexible convolution in scattering transform and neutral network with the author Đặng Đình Thuận. Welcome, Đặng Đình Thuận.
Please wait a moment.
Okay.
Hello, sir. Hello.
Yes, yes. Good morning.
Good morning, sir.
Yeah. Please continue.
Yes. Today I introduce my paper with title Flexible Convolution in Structuring Transform and Neural Network. I can move next slide.
Okay, please.
I told I can move next slide.
Yes, yes. Just make it full screen.
Yes. You can hear me?
Yeah, I hear you.
Yeah. Thank you. Let me begin. This overview.
Okay.
This overview my paper. The first slide I introduce about convolution. To implement convolution have two methods. Can implement in frequency domain and or can implement in spectral domain. The first task I will compare series of two methods. And the next time I introduce two-dimensional structuring transform. And the second task I design model in neural network. Equivalent to Scratch transform and apply this method for extract filter and integrate in to classify image and compare results two methods for classify. This overview. My paper have three tasks. The first task compare speed to speed of convolution two methods in two domains, and the second task I design model equivalent to Scratch transform, and I integrate for classify image and compare two results. Convolution occupy significant role in your world of machine learning. If we can apply convolution in frequency domain, the first we apply direct input image and filter image to Fourier transform, we perform boys-wide multiplication of two results, and I have this result. The next step, I apply inverse Fourier transform. I have a result. This overview apply one convolution in frequency domain is used using fast Fourier transform. The second method can implement convolution in spectral domain. Spectral domain is very common and regular in neural network. This input and this filter, we perform dot product operator in between spectral area and filter, and I move step by step from left to right and bottom top to bottom. This beta shows calculate implement convolution in spectral domain. It's very common, regular in neural network. This slide shows two methods to implement one convolution. The next slide, I introduce Scratch transform. Scratch transform present data separately from lining. It applies Fourier, fast Fourier transform. Scratch transform provides certain mathematical guarantee. Scratch transform have many property. It's invariant presentation, stable to deformation, and preserve information in high frequency. The next, I introduce convolution neural network. Convolution neural network is inspired by logical neural network. It includes more convolution like linear filter to detect specific filter. CNN also have a significant ability to build invariant. Maybe we use Boolean and string. CNN learn from data different present data separately. The next, I introduce the first and the second order Scratch transform. The first order Scratch transform. Can you see this picture? It have two components. The first component we use low pass filter, and the second component we use a family of complex wireless, and we perform nonlinear modulus nonlinear operator, and to convolute with low pass filter, and we contest two components. We contest nice two components. I have a output, this input and this output. If we show number of angle equal equal I. We have a output of first order class 9 outputs, and the sub size of outputs discrete I have. And the next second order class it's a combo two component. Two component for first the same first order, and we continue apply we continue apply other family of complex wireless. Yeah, this in second order class we apply two family of complex wireless. Can you more detail this? This output of first order and this output of second order. Complex wireless have two components. The first component real bus, and the second component imaginary bus. I introduce modulus nonlinear treaty. If we have a complex number, I calculate modulus nonlinear square root of sum of square two component. Two component. The next style, this is two tasks. Task 2. I design a model equivalent Socrates transform. This Socrates transform is to order 2. I design model combo. I design model combo. The first is convolution and follow rectify linear units, and after use bool layer. This block the same. This block the same first order, and the next block we implement the second order Socrates transform.
Please go to the proposed model. Okay. Hello. Professor Din, please go to the proposed model. Next.
Yeah. Thank you.
After the classification model, come to the slide number 9. Yes, slide number 9.
So.
Slide number 9. Next slide.
Next slide is can you see my screen?
Yes.
Yes. Yeah.
Please continue.
And after design model, I apply to for classification. This diagram I apply my model in diagram. The first task we for classification we apply my model in for extract filter and this style for classification. And this diagram I apply I apply Socrates transform in this style this model I apply Socrates transform, and this model I this diagram I apply CNN my model. This slide show research. I compare convolution one image input which side 64 and kernel side of kernel have a variable. Can you see this finger? This blue line we implement in frequency domain, and black and yellow line I implement in spectral domain. Can you see if we apply convolution in spectral domain? If the size of kernel have a size have a small is faster than in frequency domain, and I this finger the same research, but I apply with image have a big size. I apply Socrates transform and my model to classify in survey detect dataset. This dataset have about 7,000 images of size for 64 month 64. It have a 9 class. This is so research. This is so research 2 methods. For training, after for training 55 airbox. Can you see 2 methods have the same result? The faster work, maybe I design my model independent with Socrates transform. My work, my faster work, I decide how to my model constraint with Socrates transform. Now I decide independent with Socrates transform. But future work I decide constraint. This so reason how to constrain two methods. I can design this model and constrain with output of Socrates transform. I compare two methods. That's meaning this model learn from Socrates transform. That's future work. Thank you for listening.
Hello.
Hello.
Yes, Professor Din, from where you get the data set?
Yes, Kalyan. Yeah, yes, Kalyan. I know you are the data.
Yes.
From where you get yeah. Can you discuss about the more about the data set? What the different parameters you use?
Yeah, Jana sir, me and Madhusudan and you were taking some
Hello.
snacks also.
Can you discuss about dataset parameters?
Yeah, this is the problem, sir.
Hello.
Okay.
What are the different parameters used for classification of the dataset?
Essentially. And
what is the parameters? Dataset parameters.
I'm here, Mr. Hồng.
Okay. Thank you.
Thank you.
I will pass a message to Solanity. Please wait.
Hello.
I'm here, Mr. Hồng.
Yeah. Please continue with the next presentation.
अगर ऑथर का प्रेजेंटेशन में प्रॉब्लम हो रहा है तो वो ऑथर बोल रहा है कि कुछ करना है कि आप लोग प्रेजेंट कर लीजिए, हम लोग तो आपको दिए हैं, हम बोल देंगे, वो बोले कि नहीं तुम अपने तरफ से करो।
वहाँ पे
इंडियन ऑथर है वो आपका फोन।
Hello.
Hello, do you hear me?
Yeah.
Please continue with the next presentation.
Do you see my screen?
Not yet.
Mr. Hồng sai.
Okay.
ठीक है, तो परमार जी हम लोग सुनिए परमार जी इसको प्रेजेंटेशन करना चाहते हैं, लेकिन उनका प्रेजेंटेशन वो
Just wait me a minute.
या वो रिक्वेस्ट कर रहे हैं कि आप लोग हमारे साइड पर आप लोग कर लीजिए, हम बोल देंगे, तो बोल रहे कि नहीं आप अपने तरफ से। आप जो पोस्ट है उनको, अरे गुरुजी वो पोस्ट वाले को बोल दीजिए, उनका प्रेजेंटेशन कर लेंगे, उनको प्रेजेंटेशन कर देंगे, ये लोग बोल देंगे। खत्म चल Blocking हो रहा है।
Hello, Mr. Hồng.
My question is, yes. My question is why you scatter transform in the first step.
Hello.
I'm here, Mr. Hồng.
Yes. Why you use scatter transform? Do you hear me? My question is, why do you use the scatter transform in your model?
Okay, thank you. I will answer for your question. Because Scratch transform provide certain mathematical guarantee, but in neural network, in convolution neural network less, because it's designed by on mass, and maybe it's applied. Yes. I'm answer your question. Your question asks why apply Scratch transform in this model. You hear? Hello? You hear?
Okay, and do you have experiment when you compare with the other? You see that you will transform it better. However, do you have the experiment with the other when you compare with the scatter transform?
Yes, I saw research compare two methods. This filter I saw research when applied Socrates transform, and this research apply my model in convolution neural network. Maybe after training for 50 above, we can see this have the same research, but in the in the reality, this methods have a lower than this my model in neural network. But this methods read data separately from learning, and this methods learn from data. But after, but yeah, thank you.
Okay, and last question. Why do you choose the two layer? I see in you use two layer. One layer with conversion value and marking. Why do you use the two layer?
Why do you do? Can you repeat?
Why do you use two layer in your model? One layer consists of conversion value and marking.
So I'm not clear your question.
Yes, I see in the slide 7 you saw seven
here. Yes.
Yeah, and in the slide 7 you saw that you had the two layer. One layer consists of convolution, value, and marking. And my question is, why do you use the two layer?
The first, I consider Socrates transform have a two order, the first order and the second order. The first order and the second order. But I design this model equivalent the second order Socrates. Because in Socrates transform design two layer. That's meaning in second order that's enough. That's enough.
Okay, thank you. Thank you for your presentation. Dr. Kumar, please introduce the next presentation.
Introduce myself?
No. Thank you for the presentation.
Thank you.
Dr. Kumar, please introduce the next presentation. Yes. Okay, please present the research. Welcome, Mr. Trương Hoa Vinh, with this paper, Assessment of Structural Integrity Using Machine Learning. Welcome, Mr. Trương Hoa Vinh.
Hello, everyone. Do you hear me well?
Yes.
Yeah, thank you. Thank you, Mr. Chairman, for your introduction. So this year, my work is about assessment of structural integrity using machine learning. So for my paper, I will have 4 sections. I will first briefly give you an introduction, then our methodology. In the session 3, I will present you the numerical results, and I will conclude my presentation in section 4. So some motivation. So in fracture mechanics, which is a quite important field in mechanics, people have to identify the risk of a component failure in the presence of defects. For example, a crack. For example, here. And the common methods to this problem is to use finite element methods, or in particular, the intended version of it. However, in some application for structural integrity assessment, we need to perform uncertainty quantification, real-time structure health monitoring, and reliability analysis. And in this application, fracture mechanics parameters have to be evaluated for a large amount of crack configuration and should be performed in real times. So the direct use of the methods like finite element or extended finite element is impractical. So our aim is to develop a machine learning based method for fast estimations of the fracture mechanics parameter. And then we apply this model for the engineering tasks that I present above, namely reliability assessment, critical zone identifications, etc. Okay, now I go to our methodology. So in this slide, I present you the first scheme is the current workflows of fracture mechanics expert. So they start with the structure with the crack, then they have to measure them, and this usually take a lot of time. Then they build up a model, solving that, and obtain fracture parameter. And the whole box here depend on application. It can take several hours to several days or several weeks for one application. So our proposed approach is we replace this box by the machine learning based model. We pre-train it, and then we can use it for fast estimate of fracture parameter here. So toward this end, we will perform 2 steps. The first one is data collection. We create different crack configuration, and then we use XFAM to compute the quality of interest, which is for example, the energy release rate for its configuration. And then we develop a deep neural network surrogate model for previous model. Okay. So for the first steps, data collection. So I show you here a configuration that we are consider because this is the first step in our research. So the configuration is quite simple. It's a 2D block. For example, it represents the concrete material, and inside we have a crack, which is in the red here. And we consider the parameter of inputs includes 4 quantities: the coordinates of the center of the crack, the angle and the length of crack. Then we generate a lot of configuration like this, and here I show you the histograms of these 4 parameters of cracks, which is the center, the length, and the angle. So after having the data, we just build a simple and deep neural network. It's just L4 to R network, and we want to model the energy release rate. Okay. And the weight and the bias of the networks is identified using the common methods with the minimized square error loss function. So the structure of the networks is simple, dense, with 2 hidden layers and 20 nodes at each layer. And we use Adam algorithms for this very common methods. And here I show you the conversions of the loss function. And after 10,000 steps, we see that the validation loss become much larger than the training loss. So we stop to avoid further overfitting. Okay, so now I show you some numerical results. So having the machine learning model, now we can evaluate the energy release rate, very quickly. So it takes just less than 1 second, let's say to 100 milliseconds to compute it. And then here I show you the engineer release rates for different crack at different configuration. In the left hand side is for crack length of 0.1, and in the right hand side is 0.3. So you see that we increase the crack length, then we increase the energy release rate. In addition, in this figure we have some dots here, which is never be used for the data set to train or to train the network, but we see that this data match quite well with our model. I'm sorry. Okay, so now we apply our model to do some certain tasks in engineer. For example, reliability assessment under uncertainties, in which we have to compute the maximum of relay energy for certain configuration, certain set of configuration. Usually, to do this with the classical methods, for example, using FEM or XFEM, it takes a lot of time. But for our model, it takes less than 1 minute or 2 minutes. Okay. And here we saw that the maximum value of Gmax in terms of crack length, for example, with different angle of crack. And we see that with the crack angle is 0, we have the highest value, because at this moment the crack is quite symmetric, and the distribution of stress is equal between two crack ends. And from this value, and depend on the property of material, we can decide that if this material is going to broken or not. Okay, the same thing here. I just show you using the machine learning model to identify the critical zone. So for example, here the inside the contour is the safe zone, and outside is the unsafe zone. So when the crack locates outside the contour, then is critical. Otherwise, inside is not critical. And this contour is given by using different critical and engineer release rate. For example, if with small critical value of G, then the safe zone is pretty small. By increase the critical values of really energy rate, then the safe zone increase. And all of them I can compute using the machine learning model. Okay, with this I conclude my presentation. In this presentation, I build a machine learning based model for estimates in the fast estimates of fracture mechanics parameter, and it have been efficiently applied to perform tasks in fracture mechanics that's required to compute the engineer release rate. For the future work, I will extend to account for different boundary conditions, and this problem is very difficult, and apply it to the inverse problem. For example, when people measure some stress, strains in a structure, and they want to identify which side a crack and where is crack located inside a structure. So with that, I thank you for your attention, and I'm very welcome for your questions. Thank you.
What is FEM? Hello.
Okay. So
what is FEM?
FEM is stand for finite element methods. So for example, if you have a structure like that, you remesh it into small element, and it can contain 10,000 elements. And then you're using this method to solve the partial differential equation and to evaluate the fracture mechanic parameter, for example. And this is called the finite element methods, or FEM.
Then SIA, structural integrity assessment.
Excuse me?
SIA.
SIA.
Yeah.
So this year is
what's the use of SIA?
So it includes several tasks in SIA. For example, if you have a structure and you see a crack inside structure, you need to evaluate if the structure is strong enough to continue to work. For example, or you have to replace it, or you have to replace it, but you can postpone it, for example. Okay. And it's applied in real-time structure health monitoring. For example, if you want to monitor the nuclear power plant, so people measure something and they need to say that if this structure are continue to work in several years, for example.
Yes. Okay, thank you. How do you generate your data set?
My application is quite special because we are from engineer, so we cannot take picture, we cannot measure directly something. So what we do is that we generate structure, geometry, and then we apply the finite element methods, FEM, or extended finite element method, to compute the quality of interest, and this quality of interest, the set of quality of interest, become the data set for training the neural network.
And thank you. Any thank you. And thank you for the presentation. And Dr. Kumar, please introduce the last presentation.
Thank you very much. Stop, sir.
Yes. Dr. Kumar, introduce the last presentation.
Next presentation.
Yes. Please welcome accepting relevant social and geographic to all of internet from the movie Thanh. Please welcome movie Thanh.
Hello.
Okay, maybe we send the video for the presentation, and thank you for everyone attend this section. Now we we thank you everyone to attend this section, and this section is and this and see you in the general section in the afternoon. Yes.
Thank you very much, Professor. Yeah. Now the session is completed, I think.
Yeah.
Okay, thank you very much. See you again in the next session.
See you.